Hello, this is the proof that root 2 is irrational. So we're going to use proof by contradiction. So our first step is to make an assumption, then we're going to do some maths and try and get some contradictions to that assumption, or at least one contradiction. So let's assume the opposite of our statement. We're going to assume that root 2 is rational. So we write that by saying that root 2 is equal to p over q, where p and q are integers, which is what this little n symbol means here. We want this fraction, though, to be in the simplest form, so we don't want to be able to cancel it down. So we're going to say as well in our assumption that p and q are co-prime. That means they have no common factors apart from 1, and this fraction there therefore can't be cancelled down any further. So we're going to take this then, and we're going to start with this little statement over here, and we're going to rearrange it and try and get something that contradicts it. So first step, we'll multiply by q, and we'll square at the same time. So what we have then is that 2q squared is equal to p squared. And what we can say from this then is we know that p squared, has factors of 2. And if p squared has factors of 2, we also know that p itself has factors of 2. We can kind of use this fact then and say that p can be written as 2 times something else. We'll call that something else a, and that something else a has to be an integer as well. So we're just saying there that because it has a factor of 2, we can write it as 2 times something, which kind of makes sense. Next step then, we're going to take this and we're going to substitute back into this part. So we get 2q squared is equal to 2a all squared. Expanding the bracket on the right hand side, and we get 2q squared is equal to 4a squared, and then divided by 2, we get that q squared is equal to 2a squared. This is very similar to what we had up here to begin with, and we can see the line of logic we took here. We knew that this meant that p in the end had a factor of 2, so we'll do the same thing but now for q. So we can say that 2 is a factor of q squared, which means then also that 2 is a factor of q. And this then is we've got to the point where we have our contradiction, because we know that from what we said, that 2 divides q, like 2 is a factor of q, 2 divides p, 2 is a factor of p, and that p and q are co-prime. These 3 statements cannot all be true, but using our line of logic, they either all have to be true or all have to be false. So what we've said here then is, because we have this contradiction, this statement cannot be true. So due to the contradiction, that 2 divides q, 2 divides p, and p, q are co-prime, we know that root 2 cannot be equal to p over q when p, q are integers with p, q co-prime.